Hey there, science fans! Have you ever played with magnets? They're pretty cool, right? Magnets have this invisible force called magnetism. It's how they attract or repel things. You can't see magnetism, but you can sure see its effects. It's all around us, from the Earth's magnetic field to the magnets on your refrigerator. But did you know that different materials react to magnets in different ways? Some materials are strongly attracted to magnets, while others are weakly attracted, and some are even repelled by magnets. These different reactions are because of how the tiny particles inside the materials, called electrons, are arranged. It's all about how these electrons spin and create tiny magnetic fields of their own. Let's dive in and explore the fascinating world of magnetic materials. You can even get creative with magnets. Try making magnetic slime or building sculptures with iron filings. Or how about using magnets to move toy cars or experimenting with magnetic levitation? There are endless fun activities you can do with magnets, so grab some magnets and start exploring. First up, we have the superstars of the magnetic world, ferromagnetic materials. These materials are strongly attracted to magnets. Think about the magnets on your fridge. They are made of ferromagnetic materials like iron. Why are they so strongly attracted? It's all about the way their electrons spin. In ferromagnetic materials, the electrons in neighboring atoms like to spin in the same direction. This creates tiny magnetic regions called domains. When you bring a magnet close by, these domains align themselves with the magnet's field, making the material strongly attracted to the magnet. Besides iron, other examples of ferromagnetic materials include nickel and cobalt. These materials are super important in our daily lives. They are used in everything from electric motors and generators to hard drives in computers, and even in the magnetic strips on your credit cards. Next, we have paramagnetic materials. These materials are also attracted to magnets, but their attraction is much weaker than ferromagnetic materials. Think of it like this. If ferromagnets are best friends with magnets, paramagnets are more like acquaintances. In paramagnetic materials, some electrons spin in opposite directions, which cancels out their magnetic fields. However, some electrons still want to spin in the same direction as the external magnetic field. This creates a weak attraction to the magnet. Examples of paramagnetic materials include aluminum and oxygen. While they might not be as magnetically strong as ferromagnets, they still have important uses. For example, they are used in magnetic resonance imaging, MRI machines, a vital tool in medical diagnostics. Section 4. Diamagnetic materials, repelled by magnets. Now here's where things get interesting. Diamagnetic materials are not attracted to magnets. In fact, they are slightly repelled by them. It's like they have a force field around them that says, "Magnets, stay away." This happens because all of their electrons are paired up and spin in opposite directions. This means their magnetic fields cancel each other out completely. When you bring a magnet close, the electrons in a diamagnetic material rearrange themselves to oppose the magnetic field, creating a weak repulsive force. Some examples of diamagnetic materials are copper, water, and even gold. While their repulsion to magnets is weak, it has some fascinating applications. For instance, diamagnetic materials are used in levitating trains and in some high-tech sensors. Section 5. Antiferromagnetic materials. Magnetic moments cancel out. Finally, we have antiferromagnetic materials. These materials are like the introverts of the magnetic world. They have a unique arrangement of electrons where the magnetic moments of neighboring atoms align in opposite directions. This means their magnetic fields cancel each other out completely, making them appear non-magnetic. Examples of antiferromagnetic materials include manganese oxide and some iron compounds. While they might seem magnetically quiet, they have some promising applications in data storage devices and spintronics, a cutting-edge field that aims to use the spin of electrons for information processing.